All right, kids. 11.3, areas of what? Okay, we're going completely away from circles in this section, but there's going to be some concepts related to circles that come back into play. So we're going to start looking at how do you find areas of polygons. Now, a polygon, like a rectangle, how do you find the area of that? You know a formula for that. What is it? Base times height. Help me recall the area of a triangle. Base times height cut it in half, right? Okay. So we're going to want to make sure that we remember basic formulas that we've dealt with in the past. And to get started today, kids, with 11.3, the question we're going to try and answer is how do we find the area of regular polygons? Now, kids, this word regular, what's this word regular mean? If I say we're talking about a regular polygon, what's that mean? If I say I have a regular pentagon, what's that mean? How many sides is a pentagon? 5. But when I say it's a regular pentagon, we're saying all 5 sides are. Okay, so when I say a regular pentagon like this, kids, or regular polygon, understand all sides are what? Equal. So you might just want to jot this down. We're talking about regular polygons that are going to be inscribed inside of circles here today. Okay? So how do you find the area of regular polygons? Well, in order to be able to answer that, we're going to first of all look at areas of what and what, kids? Rhombuses and kites. We're going to find angle measures in what?
Regular polygons.
And we're going to find the areas of regular polygons. Okay? In order for us to speak intelligently about what we're going to do today, we need to know the vocab. I think it's pretty explanatory here. Volunteer to read center of regular polygon for me.
The center of polygons circumscribed circle.
Okay, what shape do we have up here, kids? That's a polygon. How many sides are there?
6.
So it's a hexagon, right? The hexagon is right here. It's regular because all sides are equal. A circle is circumscribed around it. It's just like right in the middle here, like the center of a circle, okay? So wherever I circumscribe a circle around it and it hits each vertex, that's where the center is, okay? Guys, don't bend your brain too much on this next one. Radius of a regular polygon. How about that, kids?
Well, isn't it from the point to the outside?
Yeah, it's basically from the center to a part on the circumscribed circle, but the radius goes from here to a, is that angle? Is it okay? The radius goes from here to an angle. Is that okay to say that?
Yeah.
Okay, we're going to say basically the radius is the distance from the center to, and I'm going to write it this way, center to a vertex. Okay, and a vertex meaning an angle, basically in those polygons. Okay, so you know center and you know radius. All right. I think something that's going to be very new for you today. It's called. How do you say that first word in term 3? Apothem of a regular polygon. Talk to me about it, kids.
Distance from the center to any side of a regular polygon.
Okay, now when we do this, it's this distance right here. What angles form down here according to this? Basically, it's from the center to a midpoint of the side. Okay? It's from the center to a midpoint of a side. And then lastly, central angle of a regular polygon. Any angle that's going to be formed by 2 radii drawn to what we say consecutive vertices, one right after another. So in the example here, in the example right here, the angle P is formed with M and N on that side, okay? And we'll talk about how you find that central angle, but down there it says angle MPN is a central angle, okay? P is my vertex at the center. So center of a polygon, are you okay with that?
Yep.
Radius of a polygon.
Yep.
Radius goes from where to where?
Center
To a vertex, but the apothem goes from center to a what?
midpoint of the side.
Okay, and it forms what angle there? Yeah?
Yeah.
Lincoln's looking at me like I'm crazy. Lincoln, am I crazy? All right, here we go, kids. First core concept up here today. Finding areas of what and what. Okay, let's talk about a rhombus and a kite shape. First of all, how many sides to a rhombus or a kite? 4. Define rhombus for me as best you can. Define rhombus for me as best you can. It's like it's a regular polygon with all sides equal. Good morning, Mrs. Warren.
I just have a question.
Yeah.
Track?
Yep.
I didn't want to interrupt you, but I can't, what they have on the page is not matching up. Are these what we're in for girls?
Girls is 4x1, shuttle 4x2, honey dash, that's in for girls, and like 16, 32.
But
These are alternate.
which one?
Grace is alternate, Emma, and these last 3 are alternate.
Okay, that's the problem. Okay, I wasn't adding up
Yep,
and
and
I,
then Kendall would be one right here.
for an alternate.
Yep.
Okay, so I'll list that on the page then. Okay,
Okay, all right,
so
sounds
sorry.
good.
All right, no, it's okay. It's all good.
Okay.
Okay. So right up here, you said rhombus is a 4-side figure. All sides are the same. Guys, with the rhombus right here, I'll blow this up here quickly. It says that, whoa, I didn't want to do that. Here's what I want to do. It says right here. Somebody want to read this for me?
The area of a rhombus with diagonals D1 and D2 is half of D1
Half D1, D2. Okay. Sounds like a new droid in the new Star Wars movie. Half D1, D2. How many diagonals are formed here, kids? If I know the 2 diagonal lengths right here, you can take the diagonals times each other and then cut that answer in what? Half. Okay? What's it say about the area? And I screwed this up over here, kids. I screwed this up. This should say the area of a, see the word rhombus again up here? Get that out of there and change it to kite. It says the area of a kite with diagonals D1 and D2 is what? Half D1, half D2. Half D1, D2. If you have a rhombus or a kite, how can you find the area? What do D1 and D2 represent?
Division 1, Division 2.
Diagonal 1, diagonal 2. Diagonals divide them into 2 parts, right? Okay, so let's take a look at example 1 here. If I have, first of all, in example 1, kids, what shape do I have here? Okay. Do I know the first diagonal length here?
Yes.
Do I know the other diagonal?
Yes.
Okay. This is a kite because consecutive sides are equal. So the top, the 2 short sides, the bottom, the 2 long sides are consecutive. So my area on this is going to equal half of what times what, kids? 5 times. Okay. Somebody run that value for me. How many square what, kids? Okay. Now let's just talk about this a little bit, kids. Okay. Check this out. If this is 10 right here, guys, isn't this height right here 5, kids? You guys agree with that?
Yeah.
And if this is 24 for a rhombus, isn't this 12 right here? Guys, what's 5 times 12? Half of 60 would be what? You have 4 triangles up here that have area of 30 with this right here. What's 4 times 30? 100 and 20. But by our formula, since this is a rhombus, I could have simply said, well, the area is half the product of the diagonals. So half of 24 times what? Okay, what is half of 24?
8.
Well,
I mean, just kidding.
12.
12.
I mean, just kidding, that's awesome. Yeah, 12, and then 12 times 10, what is that? 120. Matches what we already knew, doesn't it? Okay, so if you ever have a rhombus, what's true about a rhombus, kids? Mm-hmm. All four sides are equal. Or if you have a kite, where all, well, I should say two pairs of consecutive sides are equal. If you have a rhombus or a kite, what's the area formula? Yep, half d1, d2. So in this case right here, we get 120 square millimeters. Right? You see a rhombus or a kite, half d1, d2. Okay? I'd love to see you guys walking through the hallways today, just looking at people with half d1, d2, half d1, d2, half d1, d2, half d1, d2, half d1, d2. They're going to look at you like you're a little cray-cray, but that's okay.
They already do.
They already do, right? Jonathan, you're speaking for yourself or for the group? Okay, I hope this showed up on your notes a little better than mine right here. This is where things are going to start to get important right here. Okay? First of all, kids, we're talking about finding angle measures in a regular polygon. Whew! It says in the diagram, polygon. Oh my God, look at how they name this polygon, kids. That's pretty unique. All right. It says it's a regular what, kids? It's a decagon. Okay? It's a decagon. Decagon meaning how many sides? 10 sides. If it's a regular decagon, what's true about those 10 sides? They're all going to be equal. Absolutely. It says find each angle measure. Well, here's the deal, kids. This decagon is inscribed in a circle going all the way around here. And if each side is exactly the same, how many of these triangles could I form around here going from one vertice to a consecutive vertice? In other words, angle JPK right here, or KPJ if you will. That's the first question right here. How do you find angle KPJ, kids? Anybody have a guess on it? Angle KPJ being right here. Anybody have a guess on how to find that angle? How many sides are circumscribed? 10. How many degrees in that whole revolution? So I'm just going to take 360 and divide it by the number of sides I have here, right? Okay. So each angle, or if I've got 360 degrees to work with, and we're dividing by the number of sides in a decagon, wouldn't each angle that's formed here from one vertice to a consecutive vertice be 36 degrees? Okay. So let's look at angle LPK. Where's LPK at, kids? Okay. Angle LPK would be half of this right here, wouldn't it? It's half of, which would be what? Okay. How about angle, what's that say? LJP. Angle L to J to P. I like this one right here. I'm going to kind of draw this section of the triangle that we have here. We have something that kind of looks like this. Okay, that's what we're working with in L. And this is J, and this is P. We would know that this angle right here is how many degrees. What did we just say about LPJ? Or I'm sorry, LPK up there. Wouldn't this angle down here have to be 18 degrees then? So to get LJP, that's this unknown angle right here. How are you going to find that? I'm sorry? Subtract it all from 180. So LJP would equal 180 minus the 90 minus the 18, which would be how many degrees again there, Bree? Very good. Okay. All right. if there was a hexagon inscribed in that circle, how many degrees would each part be? How many degrees would each central angle be? Hexagon. 360 divided by what? Which would be, each central angle would be 60. What if there was a square in there? 4. 360 divided 4 is what, kids? No, 360 divided by 4 is 90. Okay. All right, so this is the big core concept today, kids. Anybody want to read that part highlighted in yellow for me up there?
The area of regular
N-gon, yep.
with side length S is 1/2 the product of the Polygon A and the perimeter B.
Here's the deal. They're saying I can find the area of any regular hexagon if you know, what's A stand for, kids?
Area.
The little a. Apothem and the what? They're saying right here the area is equal to 1/2 of little a, which is the, okay, we know what that is. It's from the center to the midpoint of a side, and the perimeter is a distance all the way around. Here they, though, write this right here. They say, or it can be equal 1/2 the apothem times ns, where s is a side length. What's true about all sides? And n would be the number of sides you have. So let's talk here, kids. Let's talk. This is a tough problem right here. This says the following. A regular hexagon is inscribed in a circle with what? Find the area of the hexagon. Okay, kids, here's how this works. First of all, the area of my hexagon, kids, is going to equal 1/2 the apothem little a times the number of sides we have times the side length. I'm going to go with this one right here, okay? The side lengths are going to be on the outside, and this is going to get kind of difficult. Ready for this? Everybody ready? No. Okay. First of all, do you guys all agree that if the diameter is 32, then what would the radius be?
16.
Okay, so I'm going to focus on this part of the triangle right here. Okay, I didn't draw that very well for some reason. Doesn't. Okay, I'm going to focus on this triangle right here. I need to recalibrate. Something's off a little bit. Give me a second. Okay, so this would be how much right here? 16. You guys agree that this is my apothem A right here? Okay, couple things, kids. Let's talk. Let's talk about central angles in this thing. We know that this is 90 down here. Kids, wouldn't each angle in here like this be 60 degrees? Because 360 divided by 6 is what? Okay, quick question here. Quick question. If this is 60, what's that make this angle right in here? 30 degrees. Okay. Ooh. You're telling me this is a 30, 60, 90. How, if the radius is 16, how would this distance relate? Isn't it half of 16? This would be 8. Okay. So my apothem would become 8 times the square root of 3 if you recall 30, 60, 90 stuff. If you didn't recall that, you could have used Pythagorean theorem to find it. Okay? Quick question, kids. If I want to find the area of this regular hexagon, area would equal 1/2. Do we know the apothem length right now, kids? What is the apothem? Do we know n, where n represents the number of sides to my regular hexagon? Yeah. What is that? 6 sides? And then do we know S? Do we know the side lengths? Well, I think we do because we knew that this was how much down here, kids? 8. So what's this total length going to be?
16.
So each side would be 16. So let's do this, kids. What is half of 8? 4 times the 6 would be... Somebody run 24 and 16 for me. 384?
Yeah.
So this area would be approximately or exactly 384 times which root? Times the square root of 3 square units. Oh my gosh. I want to back up here for this formula right here. To find an area, what do we need to know here, kids? What's this little a stand for? The apothem, right? What's n stand for? And then what's the s stand for? The length of each side. Okay? Holy cow. I think we better look at another example like that, don't you think? Okay. Rhombuses and kites we talked about in the first page. Half D1, D2. That's pretty easy, right? This new one, though, for a regular hexagon, when we start involving more sides than just rhombuses or kite, we have this area equals 1/2 times A times N times S. N times S is really my perimeter, right? The number of sides times each side would be the total perimeter. Let's try another one. Cool. Help me, kids. This is going to get even more intense. How about a volunteer read number 4 for me?
The mirror is in the shape of a regular monogon with 6-inch sides. What is the area of the mirror?
Okay. Nonagon first. How many sides? Okay. How long is each side? Okay. What's the formula that we're using for the area of any regular polygon now, kids? Oop, that's for the rhombuses or the kite. The one we just did up here. Core concept on the top of your page.
Half times the apothem times the number of sides.
So half times little a times little n times little s. Is that right? Okay, let me ask a question. Do we know what the apothem is? No. Do we know the number of sides in a nonagon?
Yes.
Okay, we know n is going to equal what value here, kids? Do we know the number of sides here? I'm sorry. Yes, n represents the number of sides. I screwed that up. S is going to be the side length. Do we know the length of each side?
Yes.
Okay. So the perimeter would just simply be what times what? So without saying too much, what do we need to find here to be able to find the area? We need an apothem, don't we? Okay. All right, let's do this. Let's work this a little bit. I'm going to blow this up here quickly so we can talk about this. You guys agree that, tell me where you think the center is. Do you think the center is right about here maybe? Does that look about right to you guys right here? Okay. I'm just going to sketch an apothem in here quickly. Whoops. Okay. All right, you guys okay if I call this apothem A right here? Is that okay? Now here's the situation, kids. Here's the situation. Do you guys agree, first of all, that if I've drawn an apothem here correctly, if this total distance down here is 6, what's that make this distance right here? This is a 3 right here. Furthermore, what angle's formed right here?
99.
Okay. Quick question. If I would draw maybe a central angle from, say, here to here right here. I kind of screwed that up. You get the idea, though. If I was to draw a central angle from here to here where, gosh dang it. I don't want that. Let me do this correctly. If I drew a central angle from, say, here to here, how many degrees would each of those angles be if there was 9 of them going all the way around. Each one of these in here would be 40 degrees, right? You guys agree with that? Okay, so if I would dump it in an apothem in this triangle right up here, it would take that 40-degree angle and cut it into what? So if I draw a triangle down here at the bottom, like so, like this, what's that make this angle right up top here? Okay, so I'm going to jot this in here. That makes this angle right up in here 20 degrees. Okay, this is where things are going to start to get interesting. We still have to find what dimension? An apothem. Okay? Do you guys agree that down here at the bottom, knowing that this bottom length down here is, I'm going to move that 3 a little bit, knowing that this bottom length right here is 3 inches now? Do you guys agree that if this is 20 degrees, what we've really formed is a right triangle, haven't we? And that right triangle has the following dimensions that look like this. This is 3 down here. This is my apothem A, and this angle right here is how many degrees, kids? In what type of a triangle? Reference yourself at 20 degrees. Go back to things that we did in chapter 9. Guys, you are standing on a 20-degree angle. How is 3 related to that 20-degree angle? It's an opposite leg. How is A related? What uses opposite leg and adjacent leg again? We're going to say the tangent of how many degrees here, kids? To find this apothem A right here, we're going to say the tangent of 20 degrees is equal to my opposite leg length of what? 3 over A, my adjacent leg. Oh my gosh, here we go. How many places do we carry out those trig functions when we're turning them into decimal equivalencies? Remember?
4.
Somebody run tangent 20 degrees for me. 3639. We're going to put that over what? We always put those decimal equivalencies over 1. Guys, solve your proportion. Tell me what your apothem is.
$8.24.
8.24? Can I get someone to concur on that? Okay, so my apothem A is equal to 8.24. Kids, I'm going to go back to the original problem. It said find the area of a regular what? Nonagon. We said, well, hey, I have this formula that we just discovered or worked on or talked about. My area is equal to half of the apothem times n, where n represents the number of sides, times s, where s represents the side length. We knew n and s. The thing that we didn't have was what? But now we have what, kids?
All of us.
A. Okay. So how are we going to find the area, kiddos? My area of this regular nonagon, side length 6, going to equal 1/2 times the number of sides, which is what? I'm sorry, 9 times the side length of. All right, run it through.
222.48 inches.
I'm sorry, I totally missed the first part of that.
222.48.
How many are getting 222.48? Was there a unit to that, kids?
Inches.
Inches. All right, so square inches is what we'll call this. Hang on a second. Excuse me. Thank you. You guys, this is pretty upper level stuff. Okay? Some pretty upper level stuff up here. Backing up, think rhombuses and kites. How many sides to a rhombus and kite? Your new formulas for rhombus and kite. Half times D1 times D2. They represent the diagonals. But if I'm talking any regular polygon, all sides equal, what's your formula for finding the area of any regular polygon?
Half of A times the number of extra sides times.
So if you can remember half D1, D2 for kites and a rhombus today, that's good. And for regular polygons, if you can remember half A and S, you'll be okay. All right? Kids, what questions do you have? Is there a peer eval on this, son? I think I had you do one, didn't I? 3 problems or so?
Yep.
Can you guys read those okay, or do I need to put them up there?
It's good.
You guys are good with that?
Yeah.
Okay. Take time to do that, if you would, please.